Okay, good morning and welcome to this open webinar from the Fire Protection Association of Risk Authority, where I hope to establish the risk information requirements for high-rise, massive timber buildings. I'd just like to be clear on one point. The purpose of this is not to determine whether buildings like this represent a good or bad insurance or safety risk, but intends to inform just the information, what information will be required, and most importantly, why, by those who have an interest in them surviving fires and other perils. These have been summarized in a freely available insurer questionnaire, IQ6, which we'll touch upon at the end of this talk. We have around 500 subscribers to this webinar covering building control, insurance, construction, contractors, engineers, fire safety, fire service and fire safety experts. Looking through the list, rather worryingly, there's some quite prestigious names in there, many of whom I'm sure will have a much greater depth of knowledge than mine in some areas, but I still hope we can do this topic justice. For some, there'll be elements which are oversimplified and seemingly off-piste, but we tried to create something that's at least coherent at the end of the day for all participants. Obviously, given that Risk Authority and FPA are research organisations heavily backed by the UK insurance industry, we're going to have a bias towards business and property protection, but hopefully people understand that properly. But good to state before we start. Obviously, government only mandates requirements which stop at life safety only. So the work we're discussing here today is the product of the Risk Authority Passive Working Group. And as Courtney just said, if you have any questions, we'll try and field them properly and get you proper responses to them. But not during the webinar. It's actually kind of too difficult to keep your eye on all these things at once. So as a requirement of the CII accreditation, I need to show you my credentials here. So I've been fortunate enough to work in forensic fire investigation and run laboratories at the Loss Prevention Council, the Building Research Establishment, and now the Fire Protection Association. So that's a little bit on my background and credentials. It's also a requirement to look at the learning outcomes for this and to revisit them at the end of the talk also. So I've thrown in a few seemingly strange elements into this. Drivers for change are worth touching upon, but these next two, the challenge of standards and the simple model for resilience, I believe these are important to cover briefly, because really I think that sets the scene as to some of the questions which we ask, and certainly what insurers covet when it comes to understanding how buildings might perform against a range of insurance perils. Then we look at, just very briefly, at the types of massive timber construction, the safety and insurance perils, and then we give you a walkthrough of the IQ6 questionnaire. We've set aside an hour and a half for this, but hopefully we can cover it off in around an hour and won't go too far over that. So the background to all of this, obviously related very much to sustainability, and it would be very problematic for anyone not to support sustainability and saving the planet as an ambition. But what we do find currently is that sustainability does get pursued in a very single-minded fashion, and then this can lead to the introduction of some materials and methods which we find rather confusing and consider to be quite detrimental to the construction of buildings. And really this shows this sort of single-minded pursuit. You know, it's not an excuse to leave your brain at the door. There does need to be further engagement with stakeholders so that all perspectives are properly understood. Because who knows, some of them may have quite a strong case for why things need to be done slightly differently. I'm sure with correctly done, the advantage of what's trying to be achieved can still be achieved, but just without some of the downsides. Really linked into all of this will be consideration of whether how well our building regulations can support the introduction of these new materials and methods. And will buildings still be safe, and will they still be insurable? So that's what these are the obvious drivers, and you don't have to look too far in the news to see that everybody is signing up to a zero carbon commitment going forward, and very admirable that is too. I think the trouble with this is whilst it's an ambition that must happen, we do need caveats to accompany some of these brave messages. So sort of, are we going to try and achieve this without reducing safety or property resilience, business resilience, or without reducing service delivery resilience for sort of schools and hospitals and care homes and the like, without reducing fire and rescue service support and maintaining insurability? These do need addressing because otherwise we could end up in a very different sort of environment. And we are starting to see in the news some of these issues starting to arise, and I'll touch on those later on. I mentioned, obviously, we're going to rely very heavily on standards in this brave new world, and just wanted to look at some of these. The recent issues with cladding post-Grenfell has highlighted the challenge of standards and how difficult they are to get right to properly describe how buildings will actually perform at the end of the day. Now, I don't want to underestimate it. It's very easy to criticize standards, but I can tell you from first-hand experience, it is also very difficult to create standards which are infallible and actually at the end of the day try in isolation to seek to achieve the overall objective, because there are it can be very difficult. But one of the issues that we have is scale of tests, and what I've tried to put here and invented a new word of monkeyability, the ability to try and change the outcome outside of the intent. We go from very small scale testing, and certainly you may have heard of things like the bomb calorimeter, which gives you an absolute result on whether the materials put in it can burn. They burn them in a high oxygen environment, and if they can burn, they will burn. The nice thing about this is it's very simple to describe all the materials that go into your building in their key performance of ability to burn, and it's an absolutely dependable result, and it's very cheap to do this type of testing. When we go up in scale one, we get sort of component and composite testing. The item that you see second from the left is a cone calorimeter. Now, this type of test has been really rather poorly used historically to describe the fire performance for some very large building systems like sandwich panels, where they might take a sandwich panel which in its actual life might span 10 meters. That is subjected to a testing of just a 10 centimeter sample, and obviously under a very limited heat source that this provides, it doesn't do a great deal. And actually, if you rely on those sorts of results to infer the capability of that material at real scale, you can go horribly wrong. And in fact, that is what traditionally happened, and certainly we end up with some big, almost uninsurable buildings in the food industry where certain types of panel were used, and we had incurred very heavy losses. So at that scale, they can be useful as part of the story, but at that sort of scale, it can be problematic. And then you move up in scale. The test there, I'm sure you've seen a lot of in the news, as the BS8414 test, a test for cladding systems. Now, this is a much improved test in that it at least has scale, but it's not perfect. We know it has design features missing. It doesn't have ducts and vents and windows, which can be important to the outcome of the test. We know now, but at least it's getting closer to what's actually required at the end of the day. How does it differ from the from the far left-hand side? Well, it's whilst it's a bigger test, you're testing a system of parts, and so in this type of testing, combustible materials can be tolerated because they can be part of a built-up system where they are essentially encapsulated behind higher performing materials. Of course, on the far right-hand side, we can burn down the whole building, but that's not often practical. So where we go with this, it's quite difficult to establish. Obviously, there's been a lot of talk on having a very non-combustible world, but that does curtail the type of building you can build. And if we're all happy living in World War II bunkers like the one on the left there, that's all well and good. It's got lots of benefit. It's got a lot going for it, sustainability aside. It's as fire safe as the day it was built, very low maintenance. It's got a low dependency on people, low maintenance. low susceptibility to wear and tear and through life change. So there's not much to go wrong, but really it's not wanted. What we're really looking for is a world where we can build cities which look enticing to encourage businesses to set up, and a very much nicer living and working environment. So this is more what's needed. But clearly something's gone wrong historically, because we do have a raft of some quite big buildings now which are problematic to inhabit safely now and to buy and sell. And we need, going forward with anything, we need to keep one eye on that, so we're not just creating more problems for the future. And that's very much, hopefully, what this talk will assist with in what we do. So, in effect, while standards we have got used to relying on them very heavily, it can go wrong. And certainly when it came to cladding, really the test became the focus of effort rather than the real life situation. As I mentioned, it left out some critical factors, and people relied too heavy on it and stopped looking at the building to see if there were any dissimilarities between the test and the building. So that can be challenging. To standardize really limits the variation of what actually gets experimentally looked at. So you really do have a very tunnel vision of how things respond, whereas actually, when you want to find out how many materials respond, it's good to have variety of what you actually look for. So it can lead to a very blinkered form. And maybe an example of that might be for some of the timber testing that we see. We see flames, a ventilation path through a window, but how might that change if the door was allowed to be open as well? Would that change the outcome of the test? So we need variety to understand the full picture for the full scope of how systems get used at the end of the day. Big criticism, obviously, is that any standard can simply be repeated until a pass is achieved, and all failures forgotten is a poor test. Fires can be chaotic, and we get surprised in occasional laboratory ourselves as to how with seemingly identical tests, one time it performs well, and maybe the other 9 times out of 10 it doesn't. So there needs to be some tightening there. Another key point is that fires actually happen because the world is imperfect. Basically some things, or a series of things, have to have gone wrong for you to have a fire in the first place. Yet standards tests are undertaken with real care and precision, often as not, more than the level of care of installation that you actually see in real life. And so it would be nice to see sort of testing where some imperfection is allowed, or something that represents the system as it might be in a year's time after it's been knocked about a bit. So I hope these points, without going into too much detail, show that some standards are better than others, and it's understandable that different groups of people attach a different level of relevance to them. So if obviously I'm trying to sell a product, I undertake very expensive testing and go to great effort to get a test done and hold it in high esteem, and it must be rather worrying when others may treat it slightly differently. But hopefully we can demonstrate that it's with some reason. Just by way of example, which I'm going to revisit at the end here, sandwich panels filled with polystyrene. I mentioned earlier that how they had a big impact in the food industry. And here is a simple test that we did in the laboratory many years ago. The incident fire that we applied to this built-up product is described by the red line. And this is the heat release from a gas fire that we put up against it. Now you can see that even at 50 kilowatts, 100 kilowatts, but even at 300 kilowatts, you could almost be mistaken for thinking that this product is non-combustible in its nature, or as a built-up system, it's non-combustible. However, just turn the heat up a little bit more to 500 kilowatts, and it really plays, and boy, does it play. And so great care is needed to basically put a test forward that will accurately describe the circumstances of end use. At the end of the day, you can only see as far as you look, and so tests need to be challenging enough to the realistic environment that they show you the correct response of the materials. Right, that's enough on standards. Just a quick thing on resilience also, and I hope this doesn't appear too off-piece, but I feel it's important. There are mechanisms now within our fire engineering guidelines, excuse me, to introduce new features to the design of a building, not just the architecture-driven ones of form and function and the legislative-driven ones of life safety, but now through documents like 7974, you can introduce business and insurance-driven objectives. And it starts with a company's business impact analysis. How do we hope to be served by this building? And then that sets the fire safety objectives. So rather than just think of evacuation before collapse, which, if we're being blunt, is where legislation takes you, you can start to specify other things, such as, well, I'd like the fire to be put out. There's a good starting point. I'd like to recover the compartment within a week, and I'd like to recover the business that operated within that compartment within the month and be up to normal capacity by then. These are all perfectly good fire safety objectives to set, and fire engineering is a perfectly good toolkit of parts to achieve it, but it needs someone enlightened enough in the first place to think further than just what the government needs to see, because it is a very, very low bar. Now, if we want to give a nice structure to resilience, because I hear a lot of people talk about it, and it's not always very clear to me, but the best source of information is really from Military Asset Protection, who we do a lot of work with, which breaks resilience down very simply into susceptibility, vulnerability, and recoverability. And it works for any peril, not just this. I'll just describe those in more detail. You can really describe the phases of loss as a graph that looks something like this, where on the left axis you can have your building or business capability operating 100%. And during this period, susceptibility is the actions taken to avoid fire ever being an issue. Vulnerability is about when you do have an incident, how well does the building or the business respond to that? Does it follow the dotted line and take you down to a path beyond a critical point where you have failed and you never recover? Or are there measures in place that will reduce its impact? And then finally, the final phase is recoverability. How can you regain what's been lost and get back up to that 100%? Or don't you? Do you slowly wither and die as a business, having lost all your customers? And again, follow the dotted line down to a rather poor end. As I said, this works for everything. And if we look specifically, it also provides a pecking order of the measures that you might put in place to protect your business or your building. Obviously, susceptibility, it's better to avoid than have a problem. But if you are going to have a problem, you need to curtail the amount of damage to be done. It's a secondary issue. And then thirdly, how you recover is the final stage. So susceptibility, how can we reduce the likelihood of anything happening? Well, I'm afraid in this is use of non-combustible materials. If things can't ignite, they generally don't, and not catch fire or sustain burning, then you are inherently less susceptible. Preventative management, predictive detection systems, design simplicity, security, and it may look funny being in there, but not relying on people. Having systems which we know that people can cause a lot of problems when it comes to fire, and it's no exception in this case. Vulnerability. So once we do have an incident, how do we reduce the extent of damage? Compartmentation, very obviously, provision of fire suppression systems, early detection, provision of first aid firefighting equipment, duplicating your asset. So really simply, if you can afford to lose half of your asset, then just split into two buildings. You'd be very unlucky if both of them burnt down simultaneously. So simple measures like that, and often many of these sort of measures are cost neutral. It just takes a good bit of thinking behind it. Firefighting support systems and obviously fire rescue service response and making provision for them to do a good job can be very helpful in this also. And finally, recoverability, having a good salvage plan, a good business continuity plan, insurance, other methods of achieving the same ends, outsourcing, renegotiating your service level agreements can help buy you the time that you need to keep your customers and succeed in recovery. Right, so what's all that got to do with the relevance talk we're talking about today? Well, it's probably worth having a little look at some of the recent fires that we've had, which, whilst they may well have achieved the life safety goal in that nobody died in these fires, you've got to question whether this was a good outcome. In terms of susceptibility, Well, what these all had in common were they were using light timber framing or ETICS type system, which comprised of lots of wood and combustible insulation. And so they were susceptible in the first place. Unachievable design detailing, this is a source of much debate at the moment. So on paper, these buildings probably complied in practice in trying to put them together on the building site with CAD level accuracy. May or may not be there for the taking, but many of these, there may well have been shortcomings which exacerbated the spread of fire through them. And also we need to remember that some of our building regulations just don't cover certain things like fire ingress into buildings. So buildings like this with plastic fire bricks in the side directly connecting, all parts of the building and voids by a combustible product. It's not legislated for, but can be problematic and we know has been the source of many fires. In terms of their vulnerability, well, combustible voids, poor compartmentation, external fire spread, not having sprinklers, that made them vulnerable. And actually, not real much point in talking about recoverability in this particular instance because there wasn't enough to save at the end of the day. But hopefully that puts into context. So we can now move on and talk about high-rise timber buildings. Now, the drivers for high-rise timber, really to do with their financial credentials, significant cost savings identified, off-site preparation, ease of on-site adjustment, and sustainability, which is very much part of the government's ambition currently. Let's not forget, they are also very beautiful buildings, and architecturally, they will make for a very nice environment to live and work in. But they do present some challenges, which we hope to address today. Whether you're aware or not, this is currently one of the biggest emerging insurance challenges to date. And the reason for that is that whilst light timber frame buildings, we know there have been issues around that, but these are things which, in terms of insurance, it's quite easy to price for and to work out insurance vehicles to accommodate them. But when you start building in high rise, it becomes more difficult. These are construction methods and buildings of a type and prestigiousness which are part of major property portfolios, and this becomes a very serious issue to address correctly. And so we've got the challenges of obviously they're combustible. There's been a lot of work looking at perhaps being their susceptibility to water damage. These are tall, complex buildings, mixed occupancy, and as we said, they're very prestigious. The desire of architects to present the full beauty of wood in raw. To date, we're used to where there are challenges to do with wood covering everything over with plasterboard, and we know how that can perform. But it takes us into a new place as soon as we have unprotected surfaces en masse. And we've got to say the current building regulations really haven't done a very good job with low-rise timber frame. And, so it leads to a suspicion that maybe we'll be ill-prepared for massive timber also in the same way. Now, having said all this, there are buildings going up, and there is a suspicion that the technology is being deployed ahead of technical understanding, and insurers are being asked to underwrite the bravery of other people's sustainable endeavours. Now, which is a big ask with the levels of information currently available. And we mustn't forget, insurance can't be a catch-all for technical recklessness. If the information doesn't exist, it needs to be created. Right, so looking at the use of timber, currently we see it mostly in low-rise, 2 stories or less, mid-rise, 3 to 5 stories, and tall timber buildings, which we call 2 to 8 stories. Currently in the UK, we allow for the highest built around the world, I think, unsprinkled. And but the future use, we're looking for a future of 40 stories and more, modification, upgrade of existing buildings, and extension of floor plate areas to existing buildings, that is infill. So proposed, it's obviously lightweight and absolutely ideal to get very creative with. Now the current barriers around the world are generally to do with the local building codes. And I think one of the lessons that we must learn from this, I sat in many meetings when we were talking about light timber framing, saying, well, the Americans don't have a problem with it, why do you? And really the answer to that lies in the different building regulations that we have around the world. So if you look at the US building regulations, there's an awful lot in there which actually is about business and property protection. They legislate for, it mustn't collapse, the preservation of cultural heritage, mission continuity, well, that's business continuity, and controlling moisture even in this case. So if we look at the light timber frame experience in the US, all those buildings there, if they're more than 4 stories, they'll be sprinkler protected. If they're over 2,000 square meters, they will have a significant passive barrier. If they are houses of multiple occupancy, no matter what size, they will be sprinkler protected. But in the UK, we didn't ask for any of that. We stick to our requirements of evacuation before collapse. And this has left a little bit of a bad taste. It's almost like, we see America has cars and we think we can adopt them, without the need for airbags and seatbelts, which they determined was needed to curtail the risks which were emerging there. So this is the background that we have going forwards. And just so when we start to compare evidence from other countries, look first at the building regulations, because it might not get built that way here. So types of construction, although we mentioned light timber framing and heavy timber framing, mostly centered around GLULAM, which is a post and beam type system, laminated veneer lumber, which is post and beam also, and cross-laminated timber, which is a panelized system where you construct your building out of load-bearing walls. And there are many other systems besides. So light timber, I think we're all very aware of that, where you use thin stick, and generally the last covering to go on the building will be the fire protecting plasterboard, which covers it fairly universally around. And even you see manufactured joists up there on the right-hand side. Won't be talking any more about that, but heavy or mass timber, structurally engineered wood products, very beautiful, but the idea is that when you laminate pieces of wood together, they can achieve spans and structural loading capacities which are greater than the lumber in the raw of the same dimensions. And during this laminating process, all this extra strength is achieved for a number of reasons. But obviously, you can offset perfections, resulting in more homogeneous product, so more reliable product to use. And also, let's not forget, in sustainability terms, you can build big beams out of little trees. So you can actually, obviously, it's a very convenient, can be very convenient for supply. GLULAM, where basically the laminations are used in the horizontal, and the laminations are quite thick plank wood. Laminated veneer lumber, where the laminates are very much thinner and offset from the material which they're cut but used in the vertical. Cross-laminated timber, so planks set at 90 degrees to each other, and you can build enormous walls, 20 meters plus out of this to construct buildings from. And the construction methods we talked about, post and beam, where GLULAM and LVL, post-tension construction, which we'll talk about in a moment, panelized, and timber composite. So just briefly touch on those. We have post and beam, where generally the edges, there'll be some sort of metal fixing. And again, these, in terms of discussing fire, we need to know whether these need specific protection, because these are known to be, they can be a key failure point because of their absorption of heat during a fire. Post-tension beams, this is where the load-bearing strength of the beam can be extended by having steel cable running through and tightened to compress it. And this can produce you very long spans covered by the wood. But again, if a beam is relying on material, on methods like this and structures and anchorage, this presents special risks for fire also. Then finally, panelized construction of the type we're becoming quite familiar with, cross-laminated timber, where you assemble whole walls and buildings with load-bearing walls. And finally, timber composites, where the performance of a wall, of a floor, in terms of being load-bearing and acoustics, and I'm sure many other things besides, are improved by the use of concrete on top of it. So that's a bit of an introduction. Hopefully, getting quite tuned into the insurer viewpoint of things and the historic experience. So I'll apologise, these are slightly ugly slides coming up, but this is really what the questionnaire seeks to elicit. And some of these might seem quite naive, but I think we need to be treated as naive. This is a new and emerging area, and so whilst the architects and designers may have all these answers, I suppose people like myself don't know what level of comfort to have. So we're just going to look at the requirements of just the top 6 there: design codes, business objectives, response to fire, response to water exposure, repairability, and fire and rescue service engagement. And this is the information that really is needed to understand how and if to insure a building. So going back to basics, this is not a forte of mine, but it's of other areas certainly, about the codes used to develop the fire, well, understanding what codes are used to develop the fire safety management plan. But even going back before then, what are the computer modeling structural codes for massive timber, and are they appropriate? So obviously this represents a change, and when you put a building together to make sure it can stay up and hold the loads it needs, an awful lot of computational evaluation takes place first. Now these codes were once more around concrete and steel, then transferred to wood. How do we know they're appropriate for these types of timber systems? And is it possible to evidence that? What testing has been done? I'm sure it must have been done, but we need to recognise we don't know that. Let's extend that further. Obviously, there are codes for how steel and concrete respond in fire, and loss of loading, and the estimation of safety factors and whether they're appropriate. But is the same true for massive timber? And can that be evidence to us? I've not seen much on this at the moment, but what I have seen sort of still gives you the feeling that this is emerging as a requirement, and yet we know buildings are going up, which might cause some concern, and I hope someone can correct me on this. But more to the point, we talk in terms of steel as being a generic building material, and we talk in terms of concrete as being a fairly generic building material. Is the same true of these massive timber systems, or is there variation between manufacturer and types in terms of the glues used? So when these codes are applied, might they be appropriate for one manufacturer's product, but not to another's because they use a different glue or they use things at different dimensions? The point is, I don't know the answer to that, and if I'm being asked by an insurer, I don't know the answer, but I would like to know it. So when testing it would be good to know what testing has been done to establish the suitability for the specific system and how the systems might cope with it. What safety factors are applied, and again, it's about can that be evidence, and do the codes account for change and how? So these might be changes over time. I've read some papers showing how possibly the ability to have maybe with time some systems have delaminated and use, water exposure, fire, etc. How do we actually know about these things, and what is the pedigree? Why the pictures of toilet roll? Well, simply put, we know how the structural capability of toilet paper when it's dry, and we know not to use it when it's wet. We need to be assured that we have a similar level of understanding for when we look at new building techniques and structures. So that's design codes. Now, what about business objectives? This will be probably quite an alien concept to many of you listening in if you just deal with the day-to-day of life safety. But obviously, the starting point for any insurer is that compliance is a given. And often as not, we see people trying to engage with the insurer with the masses of paperwork and the beautiful work done to show that life safety objectives are met. But actually, that's a given. We're more interested in saying, what does the owner-occupier need the building to do, and what are the insurance implications of what's proposed? So there's a question: have the insurance objectives of the business been made clear to the designer? As we mentioned before, if the owner of the building wants more than evacuation before collapse, it will have to have been specified somewhere. And how are they going to communicate that? Now, there are, as I just said, there are tools to do that, but has someone asked the question, and has it been communicated correctly? it'd be nice to know how this information might have impacted on the design, and also having come up with a solution, are the solutions themselves resilient? We know for suppression systems have different levels of fallibility and likelihood to operate. So resilience actually isn't just about what you intend to do about it, it's about the resilience of the things which will seek to achieve that also. And we need to look beyond fire also. Does it look at flood, escape of water instances, security, and the like? It all plays a part. And then we have the things which, personally, we believe really should be in building regulations, but aren't. So does it address the threats of arson, external fire ingress, imperfection, wear and tear, over-reliance on people, as we mentioned before, which aren't normally considered as life safety assessments. Right, and then it'd be nice if my slides would move on. Let me just find out why they're not. There we go. Response to fire. As I said, compliance to what is required in the eyes of the law, it seeks a life safety objective, and as such, it only seeks to delay the spread of fire. Now, that's all well and good, but 40 stories up in a building which might be constructed of combustible structure and a fire might be in a void, you've got to ask what ultimately puts the fire out and what are the measures that seek to do that. And if you haven't got an answer for that, then we're in a difficult place. We also need to consider the role of fixed fire suppression systems, how they're going to be used, and whether there's the difference between suppression and extinguishing is understood by the users. I often see people put in, suppression systems and think that nothing more is needed. But actually, a suppression system, by very definition, reduces the size of the fire to something which is manageable by others, and allows people time to get out of the building and probably time for people to actually even come in and deal with it. But if you haven't, done the part B thing of working out who's going to come and do what to put it out in the end, the end point is you run out of water or whatever the extinguishing media is, the fire rekindles and carries on. So there needs to be an awareness of this, that many of the systems which we think are about fire protection are appropriate for life safety means, but not property protection. It needs to be part of a coherent plan that gets to the objective. And as I say, 40 stories up in a very large building, extinguishment has to be an objective that you plan for. So really that takes care of sort of item 3 there. Well, are they planning for life safety or property protection? And is that properly reflected? Is there a requirement for intervention from other parties? Now, we all assume that fire and rescue services are going to turn up on a white charger and sort the day out for us. Increasingly, they are faced with situations of such complexity that might not be the case. So we'll talk more on that later. And also we need to have a good understanding of what actually gets damaged and what needs replacing after fire. And also in association with consequential damage from other systems such as fire suppression systems. And the insurer really does need to get a good handle on what are the savings versus the loss. And then we need to consider special challenges, voids, green roofs, renewables, heritage, and many other things we can describe, electric vehicle recharging, underground car parks, all these sorts of things, electricity substations, they all feature, they're really important, we need to know about them. So really when it comes to insurance, particularly to do with fire, the insurer needs all the information they need to understand what the scope for potential loss is. And this gets encompassed in a figure sometimes called EML, estimated maximum loss. And really, if you can't get to that point, if the insurer doesn't have the information to get to an EML point, it's very difficult to provide insurance at all. There's one other thing I put in there at the last minute when I was reviewing the slides this morning. How do you fire stop penetrations in combustible walls? Sounds like a very simple question, but I've never heard a satisfactory answer to it. So we are some ways off, even with the buildings which we are seeing today. Escape of water seems like a strange thing to have on a webinar that everyone expects is going to be about fire. But actually in the domestic and residential environment, escape of water accounts for greater insurance loss than fire and security combined, about 1.6 billion. And obviously, with a new building method, and particularly a timber one, where water and moisture can potentially be an issue, we need to get a good understanding of that, especially in a multi-story environment where one escape can affect many floors. And so we need to consider not only once built, but through the whole life. Where are the opportunities for exposure to water? And what opportunities are taken to assure, or what measures are taken to assure protection from water exposure during manufacture, transport, installation, pre-weather tightness, and once in service? We also need to have a good understanding of once it has been exposed, is it still fit for purpose, or does it need replacing? Because if it needs replacing, or even if there's an unknown, there's probably an insurance interest in this. Now, I'm hoping that many of you listening in on this who are much more familiar with massive timber structures have all these answers, but I'm just highlighting them because personally I don't know, and if I don't know, I'm sure there'll be many other people that don't know as well. But this is the type of information that needs communicating. We also need to know what needs replacing at the end of the day, and repairability, which is, I think, on my next slide. But there are lots of things you can do to curtail escape of water losses. It's not a much talked out thing, but safe by design principles. There are products which you may prefer. There are specific products that can help ameliorate the extent of loss quite quickly. But we need to know, again, whether how warranties hold up once exposure has happened also. So again, just like fire, we need to understand whether there's a good enough understanding of the challenge and the response of the structure to understand potential loss and this concept of EML, estimated maximum loss. It's not just about fire. And in respect of repairability, obviously we're familiar with an environment where if a building component is considered structurally sound, it may stay in place. It doesn't need replacing. But wood obviously has a beauty that's easily tarnished, and we need to constitute what the sensitivities are there. So when there is a fire or an escape of water event, what actually gets lost? And we can assume that the stuff which is now structurally incapable will need repairing. But what about if it's still structurally capable, but it's been disfigured? It doesn't look as beautiful anymore if it's slightly charred. I'm sure that will probably have to be replaced. But what about water staining? What if it's visibly okay, but future capability can't be assured? Basically, where the warranties are now invalid and something happens in the future. Would that need replacing just because there is doubt? Or we may have situations where things are visibly okay, but there's a residual smell, mustiness, smoke. And these things need to be more transparent because these all contribute very heavily to potential EML calculations. Now, a little bit about the fire and rescue service. Now, there are many people listening in from the fire service, and I hope I'm not speaking out of turn here, but it often surprises people. They've got no mandated requirement to protect property and business. And in actual fact, they're, I guess, by the Handbook of Firemanship, they're sort of almost forbidden from taking risk to save business and property. So I think there is a perception that they will take higher levels of risk to save your business and your property than they are actually allowed to do. So in any design, do the protection assumptions have a dependency on the fire and rescue service? There's going to need to be some engagement so that they actually know this. And have they agreed to make necessary provision for it? Will they always be able to assure that level of support? We're not just talking about today, we're talking about years hence. And there are many changes going on in the fire service where there are changing levels of support based on cost constraints and many other things besides. Do they have the right equipment to provide the necessary support? And finally, post-Grenfell, something which has been highlighted enormously. Have they been specifically trained to deal with the challenges specific to high-rise massive timber construction? Certainly that was put forward as a strong case about the effectiveness of fire and rescue service at Grenfell, just not being familiar with cladding fires. And how do you gain that knowledge? So there is also a need to understand how massive timber construction structurally responds to fire. Basically, you can only be assured of fire and rescue service response can only actually be provided in a building that is going to remain structurally sound for the period. There have been a few papers written to show that even once the fire is extinguished, because of heat soak up by the glues and the like, there's a suggestion that they may weaken for a period after. And of course, that is a new challenge and needs some very careful consideration also. And of course, we're talking about tall buildings, and it requires water supplies at height. So in summary, as I've just mentioned, structural stability is fundamental to the provision of aggressive firefighting measures. And where this isn't to be had, defensive firefighting might be the only strategy that keeps everyone safe, but ultimately gets the job done. So a little bit about IQ6. We produce a suite of insurer questionnaires to elicit information where technologies are new or understanding is generally poor. And we find these help with communication between the insurer and those proposing to use a system. And they can be very useful. But what this does is it seeks the information required to understand the insurance risk situation. Many questions might not currently be answerable, but actually at the end of the day, that needs to serve as a red flag. It's probably what is missing. It focuses attention on the real challenges that need addressing, and hopefully leads to an overall improvement in communication. And I'm hoping that many of you listening in will be now sort of better informed of the insurer perspective. You may not agree with it, but at least you understand where their concerns lie. And yes, so as part of this, we have in the front of it, there is the insurer scoring metrics. Now, this isn't for any user to fill in. This is for the insurer to then fill in once having read through the answers to all the questions which are provided. Now, we have noticed in the past that very helpfully, sometimes people completing the questionnaire helpfully score their own homework. But it was considered important to put this up front so you can just get a view, a good understanding of what the insurer is actually looking for at the end of the day. And these questions really look at the quality and completeness of the provision of answers, whether all the risks have been adequately considered, and whether the evidence is there, whether the standards are there to support it, and where the standards might be insufficient because it represents a new area, have justifications and evidence been provided by other means. And when you look through those, it also, has the fire and rescue has there been sufficient engagement with the fire and rescue service in doing this, and have we considered the whole lifespan of the building? So that's really all I sort of have to say on that. And really, if I had to summarize the key issues of what we've been through today, possibly too quickly, I hope it all makes sense. But the key issues are, this is a new building type, and certainly it's a new scale, and we've got very little evidence to draw upon. I know there's a lot of work going on in the background, and hopefully a lot of these questions will be answered. We need to know if the structural design codes are sufficiently developed. We shouldn't assume that the experience in other countries will be relevant to the UK. We've got to start by comparing the supporting building regulations first. Ours are particularly weak, and that doesn't help. Post-Grenfell, this type of construction does seem counterintuitive, and not too sure how it will be implemented, given the combustibility ban above 18, now possibly 11 meters, depending on which way things go. But with wood so focused, so part of the government's drive to sustainability, something needs reconciling there that doesn't make sense at the moment. I don't think it's unfair to say that the light timber frame experience would suggest caution, but that will be in people's minds. There are potentially huge insurance exposures due to the scale, susceptibility, and portfolio type, as we mentioned before, of who will actually be putting these buildings up and operating within them. I don't know whether it's a bit cart and horse, but this is exactly the sort of risk. You might like to deploy a lot of water in, but we need to consider consequential damage there as well. And someone's going to have to think long and hard about how effective a fire service could actually be in this environment. It ticks most of the challenging boxes. It's a combustible building, it's a tall building, it has concealed fires, it's no easy task. So I'm just going to review quickly, before I wrap up, just the learning outcomes as a requirement of CII, just to review what we've been through. Hopefully we've covered why we have a need, what the drivers for change are. I hope I didn't dwell too long on the role of standards and resilience here, but I do feel they were important to understand where we are coming from with this. We've been through the types of construction, the safety and insurance perils, and we have gone through the IQ6 questionnaire. I'd just like to finish with a video. This is maybe a bit off the wall, but this video is 1 minute long. For the first 20 seconds, nothing really happens. And by the end of it, everything that you see in front of you is on fire. Now, this is not the result of an explosion. This is the result of the selection and the poor selection of materials. But it comes back to, we mentioned about polystyrene sandwich panels. The situation here, this is a very standard factory. The panels are very standard indeed. To the left-hand side is a kitchen with a chimney that went out through it, but clearly wasn't properly fire stopped, and fire got into the sandwich panel itself. Now, the reason why I want to highlight this is people often think that selection of materials doesn't necessarily lead to rapid fire spread. And this video shows how wrong that assumption can be. I'll just get it going. Right, well, that was the output from a security camera, as you can see. It probably doesn't classify as leaving the audience on a high at the end of it, but I think it shows the point. When you start looking at materials and system use at large scale, things can manifest differently, and this is why we need information and research. So I shall finish off there. We've done a good job of coming in within the hour. As I said, if you have any questions or got any answers, actually, be very pleased to hear about them. A recording of this webinar will be available on the open area of the Risk Authority website. The IQ6 questionnaire is already downloadable. You can have a look through that. There's an article on high-rise massive timber framing along the lines of what we've spoken about today on my LinkedIn account, and the slide pack will be downloadable too. So I hope that was a useful hour spent. I believe at the end of this, there is some feedback sought. If you've got anything nice to say, it's always nice to hear about it, but don't hold back from saying where we missed the target also, so that we can improve next time. But thank you very much for listening in, and please do look out for other webinars that Risk Authority and FBA might be giving in due course. Thank you. Take care.